just a useless topic that you're forced to learn in school? Well, I'm here to show you just how much our world needs math. Maths not only allows us to survive, but also to thrive in the communities we create. Let's start with the basics. Conversions centered around maths are very handy to use so that we can say 1 year instead of 31,557,600 seconds. Similarly, we need maths to figure out percentages, commonly found when purchasing goods on sale. The next time you see those 2 toasters on the TV shopping channel, you'll be able to calculate that toaster 2 is the toaster for you. While eating your toast with satisfaction the next morning, you flick to the daily weather forecast. These predictions are brought to you by supercomputers that calculate mathematical equations that model the atmosphere and oceans so that you don't have to. Some of these are the Navier-Stokes equations. Yikes! On a larger scale, algebra, trigonometry, and calculus are fundamental requirements for communication systems, which are essential for our society to function, within which polynomials are solved to design electronic filters that remove unwanted and interfering signals. Another area of mathematics that has many real-world applications is logarithms, which are used to represent numbers of a very big or small magnitude in a manageable way. Instead of following a linear scale from 1 to 2 to 3, we can use a logarithmic scale from 1 to 10 to 100. Logarithmic scales are hidden within the Richter scale, pH scale, and decimal scale. This leads us into mathematics present within the agricultural industry, which we rely on to provide us with food. Here, maths allows us to improve the accuracy of soil analysis and create estimates for expenditure and crop yields, in effect, increasing the efficiency of farming to allow for maximum yield in order to sustain our growing population. Although agriculture feeds the human race, our economy drives it. It is responsible for trade and supporting entire countries. The quantity theory of money is a vital equation that can be used to see the relationship between different aspects of an economy. This equation is M times V equals P times Y, where M equals the total money supply of an economy. For example, the current money supply of Australia sits just over 350 billion Australian dollars. V equals the velocity of money, which is on average how many times a dollar has been exchanged over a period of time, usually a year. P equals the price of all goods and services, and Y equals the amount of all goods and services being sold. If V and Y are fairly constant, then M is proportional to P. This means an increase in the money supply leads to an inflation of prices and not necessarily a wealthier nation. An example of this is in the early 1920s in Germany. The government started printing more and more money to settle war debts. But as seen in the equation, as the money supply increased, so did the prices, and soon enough, the value of the German currency, marks, plummeted. By 1924, something that had cost 1 mark in 1918 now cost around 1 trillion marks. Yeah, I know, crazy, right? That is why this equation is useful to model the relationship of the variables and help banks determine how much money to print so that our economy remains stable and reliable. Through our manipulation and application of mathematics, our world becomes more developed, enabling us to look into exciting new possibilities in the fields of artificial intelligence and space exploration. So what you've seen here is only a fraction of why our world needs maths.